Hey, how's it going, everybody? My name is Abai. I'm the Embedded Systems MPI, and today I'm going to be showing you guys a little bit about like what the requirements are like for embedded systems training and certification. First up on the requirements checklist is just learning how to set up a microcontroller with a computer. Um, so let's look at that. So these here are just a few of the different models of Arduinos that we have. Obviously, if we look back up at these drawers, we have a lot of different types of microcontrollers as well. Like for example, we have the Teensies. I used one of these Teensy microcontrollers in order to control my keyboard, my mechanical keyboard that I made. But there's a lot of different components and enclosures and all that stuff. But for the sake of just the regular PI requirement, we're just going to talk about Arduinos because that's what most people are going to come in and ask about. First off, we'll see that there's obviously a lot of different form factors, and there's a lot of different there's a lot of differences between each of these models. The Arduino Mega, as the name implies, is kind of the biggest one that they have. I think and it's got a lot more pins that you can use. You got actually a double row here too, and so you've got a lot for something where you need a lot of pins. You can try to go with a Mega, but honestly, if you're using this many pins and there's not a good reason for it, I would maybe try to think about how you can maybe simplify your logic a little bit so that you're not needing as many inputs, or you can somehow combine inputs potentially. And then next going down in size kind of, we have the Uno. R3 just stands for revision 3. This is kind of the normal form factor that we're going to see. You'll see that this one has one of these typical USB-B ports right here, kind of the house-shaped ones. And then you also have a DC barrel jack. And so I believe that can take up to 12 volts, but you should definitely check the spec sheet, the data sheet for the Arduino on this. And in fact, for any component that you use, you should be checking the spec sheet in order to determine what the max voltages are like, what the max currents are like, and some other things like that. And we'll check that out here in a second for one of the boards that we're using. And then we also have three more models right here. We have the Arduino Micro, we have the Arduino Nano, which you may think looks pretty similar to the Micro, but there is actually a difference. For one, you'll see here that the Nano has a mini USB port. It's kind of like this trapezoid shape, whereas the Micro, as the name implies, actually has a micro USB port. So these are just some things to keep in mind, and there are probably also some other subtle differences between these. And then there's also, just to kind of point out another possibility, there's some Arduinos like this one, the Arduino Mini, which doesn't even have a USB port on it. And so the way you would have to interface with these is by using these two pins called RX and TX. I don't know if you can see those. They're on the far left. But those are used for serial communication. And so you would connect to those using some sort of cable, and you would connect to a computer. And so those are just some of the different kind of options we have there. So going back to our setup here, you'll see here that we have an Arduino Micro. And so naturally I've grabbed a micro USB cable, and now we have the question. Well, I mean, figuring out where this side of the cable goes in was pretty easy, but where does this side of the cable go in? You could just choose any USB port connected to the computer, right? Well, I mean, you could, and maybe it'll work sometimes, but if you want to be consistent, then there are a couple pointers that you should keep in mind. First off, the USB ports on the monitor are usually a no. For some reason, the Arduino just sometimes does not pick up the Windows computer usually sometimes just does not pick up Arduinos that are plugged into these monitor ports. I don't think it should be like that, but for some reason it is. So that leaves us with the USB ports that are actually connected to our computer. And I know there's some on the back as well, but I figured this was an easier one to look at. So here you'll see that we've got two USB 2.0 ports and then one USB 3.0 port. And the way we can distinguish that is if you can see that, you see that the one with the little blue plastic insert has an SS next to it, which technically stands for super speed. But that's actually just another way that they mark USB 3.0 ports. So here, your choice doesn't really matter. Just obviously make sure that the USB thing fits. So obviously it won't fit in this Type-C port. But if you tried to put it in the USB 2.0 or the USB 3.0 ports, then obviously it would fit. Personally, I like to use the USB 2.0 port that has this little battery symbol next to it. It's a USB port that has that is able to provide a little bit extra power, and so obviously for if we look at a circuit like this, let me see if I can get a better angle there. If we look at a circuit like this that only has like one LED, that doesn't really matter. But maybe if you are kind of getting close to the current limit, then it might make a difference. So just to be safe, and since the port is there, we'll usually use that one with the little battery symbol on it. But again, you can really choose any of these on the desktop. All right, next up on the checklist is uploading code to the microcontroller. So now you can see we've got our Arduino plugged into our computer, into one of the solid USB ports, and now let's try to see if we can get something to run on this. So one of the easiest programs to run on any Arduino is something called a program called Blink, and this is a program that you'll find in the examples folder within the Arduino IDE. But one way you can get to that is, let's just go on our computer here. So first, search for Arduino. So we open up the Arduino IDE, and here we're presented with a new file. Basically, this is an empty file, and you'll get a little bit of a kind of filler code here, but it doesn't really do anything yet. So we're going to go to File, and you'll see there's actually a little examples drop down right here, and we'll go into Basics and then Blink. So with this code, basically all it's going to do, as the code says, is it turns an LED on for 1 second, then off for 1 second repeatedly. And so most Arduinos will actually have an LED on board, usually labeled L or something like that, that you can control using a digital pin on the Arduino. This is a good point to kind of discuss the difference between digital pins and analog pins on an Arduino. So with the digital pin, you can output, but you can also input. They're called digital I/O pins. I being input and O being output. So if you had, I don't know, if you had some sort of digital sensor, which you basically wanted to see whether it was on or off, maybe like a switch, or a push button, where you basically want to see is it pressed or not. Then you can hook something up like that to a digital I/O pin and use it as an input. And when you do that, then you'll be able to use the value from that for any calculations or anything like that you want to do. You'll see here in our code that we're setting the pin mode of an LED titled LED Built-in to output. So LED Built-in is basically just a placeholder for whatever the LED pin is on your specific model of your Arduino. In our case, it'll be pin 13, but there are some Arduinos where it'll be a different pin potentially. So that would be something that you would want to check the data sheet for. Again, we'll get back to that. But yeah, so we're setting the pin mode of that pin to output, which means that we want to drive a signal from pin 13. Um, so that's what that's doing there. And I know I said that we also have analog pins. Obviously, we don't have any of those in this program here because the only thing we're controlling is an LED, and an LED can take a digital signal. But with analog pins, the analog pins can only be used as an in on the Arduinos. But basically, it'll read a value between 0 and 1024. Or let me rephrase. It'll read a value between 0 inclusive and 1024 exclusive. So you can have something between 0 and 1023 technically. There are 1024 possible values, is the better way to say it. And so again, this will be kind of, instead of just a high voltage or a low voltage, suddenly you're looking at a range of voltages. But now it's being, instead of like going between 0 and 5 volts, when the Arduino sees that information, it's translated into an integer between 0 and 1023. So that's how the analog inputs work. We'll be able to see how that works here in a second when we go into kind of how to actually code up a circuit for our Nightlight. But yeah, we'll get back to that in a second. So now looking at the code again. So in the void, these two functions, void setup and void loop, are required for every Arduino program that you are going to compile and upload to an Arduino. So yeah, so in void setup, as the name kind of implies, this is stuff that's only going to be run once. However, void loop, again as the name implies, is stuff that you are going to be running, endlessly. And so every time that void loop reaches the end, it's just going to kind of call itself, and you're going to go back to the top of void loop. So when we're dealing with digital pins, we do have to set this pin mode to either output or input. So for an LED, that would be output, but for maybe a push button or something like that, that would be input. And that's the only thing that we have in our setup this time around. But let's look at our void loop. What are we doing here? Well, remember that this code is going to turn an LED on for 1 second and then off for 1 second. So here, we are digital writing to, again, our LED built-in, which is going to be replaced by 13 when we compile the code, because that is the pin number of the that's connected to the LED on our board. So we're digital writing high to pin 13, which means that the LED will be turned on, basically. And then we have this line, delay 1000. What does that do? So this 1000 represents 1,000 milliseconds. So that is equivalent to 1 second. And so just be mindful whenever you're using the delay function that the number you put in is not seconds, it's milliseconds. Then we're going to have another digital write, and this time, instead of setting it to high, we're going to set it to low. That's going to turn the LED off, essentially. And then we have another delay for 1 second. So basically our program is doing exactly what the little header here told us it would do. So that's good. I mean, without further ado, we can just run this, right? We can just put it on the Arduino. Not quite. There's a little bit of setup we need to do. Check out the Tools tab here at the top. So we have a couple things that we need to set. The first thing we need to set is the board. You can see that it's already set here because I did some stuff, movie magic. I did some stuff before I started filming. So it's already set to Arduino Genuino Micro, which is the board that we're using. But maybe if you were using an Uno, for example, you should make sure that Arduino Genuino Uno is selected. The other thing that you need to make sure you select is the correct port. The version of Arduino, the Arduino IDE, IDE stands for Integrated Development Environment, by the way. The version of Arduino IDE that we have on our computers will tell you usually which COM port is the Arduino, or which Arduino rather. You can see here that it says that COM28 is the Arduino Genuino Micro, but on some older versions of the IDE, it didn't necessarily tell you this. Just be a little bit wary. One way that you can actually kind of be sure that you selected the right one is to go to Device Manager. So just search for Device Manager on one of your computers. and you'll be greeted with a window, which is just kind of saying that you're logged on as a standard user. That's fine. And so you'll get to see kind of all the devices that are connected to you, to the computer. We're specifically interested in this one, in this category titled ports, common LPT, because the Arduino is connected to a COM port. So here we can see that Arduino Micro is COM28. So that's one way that we could verify that if we couldn't see that in the Arduino IDE, but luckily we can, so we don't need to do this step on these computers. So with that, we've now set both of those things, and now we are actually ready to compile and upload this code. The Arduino IDE uses the terminology verify and upload. You can actually just click upload, and that'll automatically verify it. So yeah, just a quick tip. So I'm going to click upload, and so you can see it's compiling the sketch now. Okay, cool. And now we're done uploading. So now we can actually see here on our Arduino. I'm going to have to bring the camera a little bit closer. You can see that we have our little blinking LED. If you consider a blink an on and an off, then it blinks once every 2 seconds. So cool, our code runs. Or not our code, but someone's code runs. So next, performing basic troubleshooting on the microcontroller. Sometimes we'll get situations where our microcontroller is not doing what we expect it to, or we're not able to upload code, or something else is going on. This is a good time for us to introduce something called the serial library. So let's go back to our blink example here. So remember that I said serial is a type of communication that the Arduino can use, but it can actually also allow the Arduino to print through your little USB cable. It can print text to something called the serial monitor. And so what that can look like, if I just write up some code here real quick. Okay, so what does this one do? Serial.begin. So serial.begin is basically just going to initialize this serial buffer, and we're setting the baud rate, which is basically just a frequency, to 9600. That'll be important later on here when we're debugging things. So keep note of that we set that to 9600. Okay, next, we want to actually print a message. So let's say, at the beginning of every loop, let's say serial.print line, which means that it's going to print whatever I put here in the arguments, and then it's going to print a new line, which will put the next thing that I print on a new line. So let's say the classic hello world. Let's make it a little bit spicy. Let's say hello world, you suck. Cool. So we've got our initialization of our serial library, and we've got a use of the serial library. So let's save that. So since this is an example program, we'll have to save it for ourselves. So let's just save it as blink with serial or something like that. And you could just save in the default folder, but if you wanted to save somewhere else, that's totally fine too. So you can do that. It's done saving. So now what we can do is we can upload. We already set our port and our board, so we don't need to do that again. But if you wanted to just do a sanity check, you can actually see that here down in the bottom right corner of the Arduino IDE screen. Okay, so now that's done uploading. So just to confirm, we can see that our LED is still blinking. Yep. So our code is still working. So now let's open what's called the serial monitor. You can get to this 2 ways. First, you can press Tools, and you can go down to Serial Monitor and click that. But the way I like to do it better is you'll see this little kind of button here in the magnifying glass. And then when you hover over that, it will say Serial Monitor. So if you click that, it'll open the same thing. And you can see that we're getting our we're getting our prints of hello world, you suck every 2 seconds. But one issue that people will run into somewhat often is they'll get something instead that looks alright, So unfortunately, I wasn't able to replicate the issue that end users have, but it is something that I've seen before, where if you see here, we set the baud rate in our code to 9600, but if I go to my serial monitor and I had my baud rate set as something else, like 115,200, then sometimes the serial monitor will print gibberish, and people will be like, "Oh, why am I getting gibberish in my serial monitor?" And so in that case, you can usually just check to make sure that the baud rates match. Obviously, this time for some reason that just didn't work. Sometimes debugging just be like that. So another thing that might happen is that the code fails to upload. So remember how we set the board and the port before we uploaded our code? That's something that people forget to do pretty often. And it's a very easy thing to check. So make sure that you're checking for that. So let's see what board they have. We have an Arduino Micro. So like, for example, let's say we changed it to an Arduino or Arduino, and then we tried to upload this. Well, you'll see that our upload actually gets frozen because it's not able to upload this program to a micro. It's not able to upload an Uno code to a micro. I mean, it makes sense, right? You have to have the right model of the board selected. So this is something where like it gets frozen, and then if you let it time out here, which I won't let it do, but if you did, then you would this like kind of area would turn red, and you would see some sort of error there. But we won't wait that long. A similar thing can happen if you choose the wrong port, or if you don't have a port selected at all. So if you chose COM1 instead and tried to upload, then that would also cause a similar issue. Cool. So that covers debugging. Let's look at our next section. So this is writing code to control a simple Nightlight Circuit. So let's look at our circuit right here. Alright, so here we've got a simple Nightlight Circuit. So let's explain a little bit about what's happening here. We have a photoresistor right here. A photoresistor will basically, it increases the resistance on the circuit based on kind of how much light or how much light intensity there is on it. So if I put my finger over it, for example, then it would have a greater resistance than if I just let it be out in the light. And right now you can see there's a little shadow on it from my camera. And if I moved that away, then it would have even more. But obviously, for the sake of the video, we won't do that. And so that is over here. It is connected to pin A5. So how I'm reading these is you can see that with this ground, you can see it has a little white label on it. And so I can see that ground is this pin, and the little ground label is to the right of the pin. So if I look to the right of this pin, I can see that it's A5, and that's the pin that wire is connected to. And so there's a little bit extra circuit stuff going on here, yeah, this is basically just, it's called a, this would be a pull down resistor, and what that's basically doing is it's saying like, okay, well, if you had like a max intensity of light or something like that, you're not just gonna like totally like complete the circuit. There would be some resistance in the circuit that would prevent like a short circuit from occurring. And you can see here that we've connected our ground on our Arduino to the ground rail here, this minus rail, this blue rail. And then similarly, we've connected our 5-volt pin, which is this one right here. We've connected that to our positive rail. And again, we're doing that on the other side too. We connected our ground to our ground, and then we're pulling our ground from here. On this side, we actually didn't need the 5-volt, so it's not connected to this rail. But on this side, what's going on is we have this LED right here. We have another resistor again, and then that is connected to pin 4. Pin 4 is a digital I/O pin. A5 on the other side, as you might have guessed from the A, is an analog in pin. And so what we're doing here is we're basically saying, okay, pin 4 gets to drive a voltage, either high or low, to this LED. And again, we want to make sure that we have a resistor here because if we don't, then we're basically the LED itself does not have that much resistance, and so we would have a lot of current flowing through, and we could potentially short circuit here again. So we want to avoid that. So that's why we're using this resistor to kind of make sure that doesn't occur. We're basically reading whatever comes out of pin 4 here, and we're turning, and the LED will turn on or off based on that. And so then the rest of the logic is actually going to be happening inside the Arduino. So let's take a look at what our code might look like for that. All right, cool. So you'll be provided most of this circuit during your certification. You'll just have to say, you'll just have to put in the wires that say, like, okay, which pin is the photoresistor connecting to, or which pin is the LED connecting to, and you'll be able to choose because you'll be writing code for that. So speaking of writing the code, let's try to do that. All right. So how we're going to make a new file? We're just going to press new. That was easy, right? So let's see here. So again, we're greeted with kind of our blank void setup and our void loop. One thing that I like to do to start off is just put all of my pin numbers into constant ints. So how we're going to do that is outside of our void setup, before our void setup rather, we can do const int, and then let's call this one. Let's do abbreviated form of photoresistor. So maybe we can do PR, and then we'll say pin, and we can set that equal to. So it was pin A5 that we were using. Since this is just an int, we can't put the A part in, but we're going to say 5. And then similarly, for our LED pin, we said that was a digital pin 4. So we're going to do const int. Let's say LED pin. Let's say that's 4. Now, just a quick technicality here. There is technically an LED on the Arduino Micro and most Arduinos that we could have used an onboard LED. We could have said we're going to use pin 13 instead, but just for the sake of the certification, we are going to use an external LED. Just wanted to clarify. So going back here, so now that we've defined both of those things, we're going to go into our void setup. First thing we're going to do, I do want to use some sort of a serial print to see what the photoresistor value is during our loop. So let's do our serial begin again. We're going to do serial.begin, and then let's set our baud rate to 9600. It's a pretty good value, pretty standard. Next, remember with digital pins, we need to tell the microcontroller whether it's an input or an output. Since we're kind of trying to turn on or off an LED, that would be an output. So we're going to say pin mode. Remember, since we just instantiated a variable for our LED pin, we can just use the name of that. And this is actually useful because if we decide actually later on, actually I'm going to change the LED pin to pin 6 or pin 8. Instead of having to go through our code and change number 4 in every place that we used it, we can instead just change the value of the variable LED pin once. And we've essentially changed it everywhere. So we're going to do that, and then of course we're setting the serial output, so we're going to write output. That is all we have to actually do in our void setup, because with the analog pins we don't have to set that up, we can just use them. Now let's move to our void loop. This is the stuff that we're going to be doing kind of constantly. First off, I'm just going to throw in a delay here of 50 milliseconds. Just so that we kind of have a pretty good idea of how often we're sampling the photoresistor. I don't know, just a thing that I like to do. You don't have to do that, but for timing's sake, that's what I'm doing. Next, we need to figure out what the value of the photoresistor is, right? We can just create. We can go back up to the top of our code here, and we can create a variable for that. We can just say int PR value. Let's say our PR val is also valid, and we'll say, we'll start that off. And we actually, since we're going to be setting it every loop, we don't have to actually set that up here at all. So the first thing we can say is we're going to say, okay, PR val, and we're going to set it equal to something. What are we going to set that equal to? We want to read the value from the analog pin that the photoresistor is connected to. So we're going to use a function for that called analog read. Analog read. And we want to read from PR pin, so we're going to say PR pin. And remember that that's going to give us a value between 0 and 1023. So, you know, I'm going to pretend like I don't know what the value of the ambient lighting is right now. So let's just say we're going to print what that is. Let's actually get a little creative here. Let's do something like current photoresistor value on one line. And see, and notice that I did print and not print line. That just means that it's not going to start the next one on a new line. So I can essentially combine two prints into one line this way. And for my second print, I'm going to do serial.print line this time. And I'm going to just say PR val. And that'll just put the value that I'm reading from the photoresistor into the serial monitor. And then I'll have my delay of 50. So let's try compiling this and uploading it to our micro and see what we get. One thing you'll actually see on your Arduino when you're uploading is that there will be two lights labeled TX and RX, which conveniently, TX is for transfer, and then RX is for read. I believe that's the terminology. That basically means that like whether or not the Arduino is transferring stuff over the serial communication or reading stuff from the serial communication. Obviously, when you're uploading code to the microcontroller, it's going to be doing both of those things simultaneously, and so you're going to see those lights flash a lot while you're uploading. So just something to look for to make sure that your code is actually uploading. So let's look at our serial monitor now, and we can see that we're getting a value of about 350 being printed, or 400 now actually, being printed every 50 milliseconds, like we said. So the cool thing is now, is if I put my finger, you can't see this unfortunately, maybe you can. Let us see. Let me move my giant mouse out of the way. So I've got my photoresistor right here, and if I put my finger over it, then if we look back at our serial monitor, we see that the current photoresistor is now under 100 actually. And then if I lift my finger off again, then it's back up to 450 actually this time. So we can get a pretty good idea for what the kind of ambient light is. It's somewhere between 350 and 450. And then if I put my finger over it, which we're kind of considering as the dark mode, then that'll be kind of that'll be around 100 for us. So let's set our threshold between like dark and light at maybe 200. I think that's pretty reasonable, just to kind of have some error on both sides. In this case, we want to turn the LED on when it's dark. So we want to turn the LED on when the photoresistor value is under 200. So let's say if PR val is less than 200, then we want to, again, we're using the digital write that we used in the Blink program. So we're going to say digital write. And then we're going to use our variable LED pin, and we want to set this to high when it's dark. And then we'll do an else statement. I'm going to actually fix my formatting here a little bit. And we're going to do an else statement. So basically, what this is saying is when PR value is greater than or equal to 200, here we're going to digital write to LED pin again, but this time we're going to set it to low. Because if it's over 200, then that means that, or if it's equal or over 200, then that means that there is ambient light, and we don't want the nightlight to be on. So you know how nightlight works, basically. So we can upload this again, and now what we'll actually see happen is when I put my finger over the photoresistor, the LED lights up. When I lift it, no more. Isn't that pretty neat? That's a very simple thing that you can do compared to what a lot of other people do using these Arduinos and other microcontrollers too. So now that we've written that code, finally let's look at kind of the electrical limitations of the microcontroller. Remember when I said we were going to look at the data sheet? That's what we're going to do now. Basically, if we wanted to see, maybe I have a motor that uses it has a peak current of 1 amp, maybe, and it's a 5-volt motor. And I want to see if I can connect this directly to my Arduino or if I need an external power source or something like that. So let's see. So let's go to, or actually, let's just search Arduino micro data sheet, and we'll get something that works. So here's a PDF of some sort. If you scroll down a little bit, you'll find a summary, and this is usually all the information you'll need. So you can see operating voltage 5 volts, and also we have a 5-volt pin on the Arduino itself, so we know that the voltage is fine. But now, pay attention here to the DC current per I/O pin. It's actually only 40 milliamps that we can use per pin. So obviously that's nowhere close to 1 amp. So we would have to use some sort of external power source in order to power our motor if we wanted to control it using the Arduino. We could still connect signal lines to the Arduino micro from the motor, so we could still control our motor. We would just have to be a little bit wary of how we're wiring things and making sure that we're not powering the motor only from the Arduino, because then it will either not work or you would cause some sort of issue with the circuit. So yeah, that's pretty much it for the training. Thanks so much for watching the video. I hope you guys learned something, and then hope to see you guys in a checkoff soon. See ya.